Right. So, given a first order differential equation in the form of dy dx is a function of x and y, and if that function can be separated in terms of its x and y component, then dy dx will be given by the x component times the y component, and then this we can solve by the process of separation of variables, which basically means we want to get the dy with the y term and then the x with the dx term. And so this video will look in terms of several examples as to how this process works. Right. So let's look at a few problems, and let's first go back in terms a little bit of what you remember from your calculus classes. And so you had, if you had something like this, 4y dy equals 3x dx, well then this could be integrated, because we can integrate this side with respect to x, and we can integrate this side with respect to y. And if we did this, we ended up with 4y squared over 2 plus c1, and over here we ended up with 3x squared over 2 plus c2. Right? And then of course this could be simplified to be 2y squared plus c1 equals 3x squared over 2 plus c2. But then again, we could then see that we were able to do this, right? But now let's say we actually started this problem back one more step. And so now the original actually looked something like this. And so we started, where was this way? And so now here, we can see that the dy is with the x term and the dx is with the y term. But again, in order to do this, we need to get them both paired up correctly. And so the way we can do that is we can multiply everything by 4y and the 3x. And so when we do that, so over here the x's would go away and we're left with 4y dy. And then over here, the y's would go away and we're left with 3x dx. Right? And again, from here, we can then go on to the process of integrating. And so now we can integrate this. And as we saw before, this would become 2y squared plus c1 equals 3x squared over 2 plus c2. And we had that up previously, right? Okay. And then we could get our c's on the same side. So let's take this one over to the other side. And we have 2y squared equals 3x squared over 2 plus c2 minus c1. But then I really don't need to have a c2 and a c1, and so we'll let, and we're going to let c equal c2 minus c1. And so I'm going to rewrite this as 2y squared equals 3x squared over 2 plus c. And we're done, right? So again, the process we want to do is we want to get the y's with the dy's and the x with the dx, right? So let's look again in terms of how this works. And in terms of another example, right? So given this one, dy dx equals 8xy plus 3y, right? So again, first off, on this side, we want to get the x and y separated. And so if I look at that, I notice that the y is common to both terms, so I could factor that out. So we'll take the y out, and we get 8x plus 3, right? And now we need to get everything associated correctly. So let's first take care of our dx. So we'll multiply everything by dx. And so we get dy equals y, 8x plus 3 dx. And then now we can divide by our y. And we have dy over y equals 8x plus 3 dx, right? So again, we're now in a spot where we can do our integration. Okay? And so we can now then integrate both sides. And so we'll do that. Let's continue it up at the top here. Okay. And so if I integrate, and remember we integrate dy over y, this was integrated you in terms of your natural log. And then if I integrate that, we would end up with 4x squared plus 3x plus c. And so we have found that one solved, right? All right. So let's look in terms of a few more of this process. All right. And so now we have in terms of this one, dy dx equals x y squared. So again, with the same process, we want to get the x's together and the y's together. And so this one, again, if I go through each step individually, first take care of my dx. And we'll bring that over. So we get dy equals xy squared dx. And then I want to bring my y over. So let's divide everything by y squared. And so we get dy over y squared equals x dx. This, again, we can now integrate. And so this would be the same thing as integrating y to the minus 2 dy, integral of x dx. And if I integrate y to the negative 2, we get negative y to the minus 1 is going to equal x squared over 2 plus c. And then, of course, this I could also write as negative 1 over y equals x squared over 2 plus c. Right? And so we've integrated that one. Right? Okay. So let's go on to one a little bit more complicated in terms of the separation process of my variables. Right? And so now I have one that looks like this. So dy dx equals 3x x y squared over y plus x squared y. Right? So again, if I look in terms of the top part, I see that x is common to both terms. So let's first start by taking the x out of the top. So we get x. This will be 3 plus y squared. And then on the bottom, we can take a y out. And this will give me 1 plus x squared. Right? Okay. And then again, we want to get things separated. So again, let's go through this as a process. And so let's take the dx over first. Okay. And so we get dy equals, and I'm going to rearrange this as I do this, make it a little easier. This is going to be 3 plus y squared over y. And this will be x over 1 plus x squared. And then dx, right? So I rearranged it as I rewrote it just so you can see that my y terms are now all together. And so now when I go to the next step, which is going to be to divide by that. So we're going to divide everything by this, all this stuff here. And divide this by 3 plus y squared over y. And when we do that, we'll see in terms of that process, and of course that will flip that fraction over when I do my division. And so we end up with y over 3 plus y squared dy equals x over 1 plus x squared dx, right? So yeah, 1 divided by this, again, remember in terms of dividing fractions, leave the first one alone and flip the other one over. And so that's why we ended up with what we have here, right? Okay. Now the next step is to integrate this. And so we're going to integrate both sides. And so we'll do our integral. And so this time, let's do our integration by substitution. And so over here, let's let u equal 3 plus y squared. And then the derivative of this, du, would be 2y dy. And just so we have different letters here, let's go over to this side, and let's say that this is going to be v. And so v is going to be the 1 plus x squared. And then the dv is going to be the 2x dx, right? And again, remember, you wanted to pick your v or your u such that the derivative was going to closely match that other term. And so here, 2y is similar to y, and 2x is similar to x. It's just a matter in terms of a factor. Right? So that factor is going to be 1/2. And so now we can make our substitution, and so we'll get du over u. And then on this side, just to keep the colors matching, we'll do this in red, 1/2, and this is going to be dv over v. Right? So now we want to do our integration, and so again, remember that in terms of du over u, that is your natural log, and so this is going to be 1/2 the natural log of u equals 1/2 the natural log of v, and then plus c. Right? And then the last step in this process is we need to substitute back in, and so we end up with 1/2 the natural log of 3 plus y squared equals 1/2 the natural log of 1 plus x squared plus c. And we have completed that one, and this time we made use of our substitution rule. Right? So one last one, this time involving trig functions and how this works. And so one involving sine and cosine. So I now have sine y dx plus cosine x dy equals 0. So we're going to first start by taking, let's take the cosine over to the other side. So we can start getting these separated a bit. So I end up with sine y dx is going to equal negative cosine x dy. Right? And so then here is just a matter of dividing by the sine y and dividing by the cosine x. And so when I do that, we end up with dx over negative cosine x is going to be dy over sine y. Again, I divided both sides by the negative cosine, and I divided both sides by the sine, and I end up with this. Right? So I now get to this form. Right? Well, remember in terms of your trig functions, that 1 over cosine is the same as secant, and 1 over sine is cosecant. And so we can rewrite this as negative secant x dx equals cosecant y dy. And now we can do our integration. And so we'll integrate both sides. And so in terms of secant, when you integrate, you get in terms of this secant x plus tan x. And then over here, you get the natural log of cosecant y minus cotangent y plus c. And we integrate that one in regards to y. So again, the process here in terms of separation of variables is we want to get our x with the dx, we want to get our y with the dy, and then from there we can proceed on in terms of integrating and coming up with our answer. And then of course, again, with all of these, if we had a bit more information in regards to our x and y, we could then also determine the value of c in terms of these problems we just did. And with that, that will conclude this lesson on separation of variables.